Hello students, I hope you did well in KCET 2023. So today we will be having a discussion of physics paper. So look at the first question. The torque acting on a magnetic dipole placed in a uniform magnetic field is 0 when the angle between the dipole axis and the magnetic field is. For this you should know the formula for torque acting in a magnetic dipole placed in uniform magnetic field, that is torque is equal to m cross B. So which is MB sine of the angle between the magnetic dipole and uniform magnetic field. So if you want the torque to be 0 here, therefore that is possible only when theta is equal to it should be 0 degrees. Okay. So the correct option here it is 3. Now let's go to second question. The horizontal component of Earth's magnetic field at a place is 3 into 10 to the power of minus 5 Tesla. If the dip at that place is 45 degrees, the resultant magnetic field at that place is. We all know that the horizontal component is given as B cos of the angle, that is the dip angle, delta here for us. Okay. So the B is going to be BH, which is 3 into 10 to the power of minus 5 upon cos 45, that is 1 by root 2. So this is going to be 3 root 2 into 10 to the power of minus 5. Okay, so the correct option here it is option 2. Now third question, a proton and an alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of the radii of their circular paths is. We know the radius formula when the charges go in uniform magnetic field, where R is equal to mv upon qb. Since the speeds are same and also magnetic field is same, so R for proton upon R for alpha particle is equal to mass of proton upon mass of alpha particle times charge of alpha particle upon charge of proton. Okay, so if you take mass of proton as m, then mass of alpha particle would be 4 times that, and if you take charge of proton as, let's say for example q, then charge of alpha particle would be 2 times that. Okay, so q mm gets cancelled, 2 1s are 2 2s are. Therefore radius, the ratio radius of proton to radius of alpha particle would be 1:2. So option 2 is the correct answer. Next, a moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. The galvanometer resistance is 90 ohm and the shunt resistance has a value of 10 ohm. Okay, so if there are 50 divisions in the galvanometer turned ammeter on either side of the 0, its current sensitivity is. First of all, the current sensitivity definition is number of divisions upon the galvanometer current. So first we need to find the galvanometer current. The range, the maximum value that it can measure is here, it is 5 milliampere. So we know that if you take this as, let's say, the resistance of the galvanometer, and let's say this is the shunt resistance, let's say that is S, and let's say this current I is coming, so here current is Ig, so the current through this one will be I minus Ig here. Since these two are in parallel, so therefore Ig into Rg should be is equal to I minus Ig into S. Okay, so we'll have to find Ig. So Ig into Rg, here it is given 90, which is equal to I is given 5 milliamperes minus Ig into S is given 10. So 0 0. So therefore 9 Ig is equal to 5 minus Ig. So that is 10 Ig is equal to 5. So 5 1s are 5 2s are. So therefore Ig turns out to be 1/2 milliampere. Okay, that is Ig for us. So the current sensitivity S is defined as now the total number of divisions, that is 50 upon the current, that is Ig, which is half milliampere. So that is half into 10 to the power of minus 3. So it will become 100 into 10 to the power of 3 here. So that will be 10 to the power of 5. So I hope you can see the answer is option 2. Now, a positively charged particle of mass m is passed through a velocity selector. it moves horizontally rightward without deviation along the line y is equal to 2 mv by qb. Okay, so with a speed v, so that is already given here. So you have a charged particle which is moving with the speed v here. Okay, and the electric field is vertically downwards and magnetic field is into the plane of the paper, as you can see in the picture. Now the electric field is switched off at time t is equal to 0. The angular momentum of the charged particle about origin O at t is equal to pi m by qb. Okay, that is the question. First of all, we know that here the moment the charged particle enters the field here, electric field is 0. So it is moving with speed v. And if you can look at the direction of the magnetic force, because that is the only field which will act or which will exert a force. So v cross b, that will be upward. Okay, so if this is the origin here now, so the center will be somewhere here, let's say. Okay, in that case it is going to take this kind of circular path, since it is only magnetic field here for us. So the time is given pi m by qb. We know the time period is a 2 pi m divided by qb. So as you can see, the time instant is pi m by qb, which is half of this one. So for half of this one, exactly it will try to come out of the magnetic field here now. So in that case, from the y is given 2 mv by qb, which means that this is that y here, which is basically 2 times the radius of the circle, because r is mv by qb for us. R is mv divided by qb. So that is the radius. So it is twice of that. Okay, so which means from here to here, this total distance would be, this is 2r and this is also 2r, which will be 4r. So angular momentum L turns out to be r cross p. So here it will come out with the same velocity v. So mass is anyways given m. So and the r position vector from here to here is that. So angle between them is 90. So it will be mvr itself, because sine 90 will be 1 here for us. So in that case, this turns out to be m into v. Since the v is selected in such a way in the velocity selector, therefore E is equal to v into b. So therefore v is equal to E divided by b here. So that should be the velocity. So E upon b, and radius is what, mv upon qb. Okay, so v is again E by b. So in that case it should be m squared and E by b. So you already have one more E here, so that should be E squared, okay, divided by q, and you have b squared, and in the v also you will get one more b, so it should be b cube. But none of the options is matching. Okay, so I think we will go with a bonus for this one. Or otherwise, if we had given, instead of a positively charged particle, he had given, let's say, electron. Okay, then in that case the electron would have radius that only. So electron would have come, the center would have been at this particular point, because this would have been the radius here for us. So it would go like this through the origin itself. So therefore the angular momentum would have become 0, because the position vector is 0 here. I hope it is clear. Okay, so if we had given this charged particle as electron, it would have been 0, but otherwise the answer turns out to be this one. This is the angular momentum. So it's a bonus for us. Next, the Curie temperatures of cobalt and iron are 1400 K and 1000 kelvins respectively. At temperature 1600 Kelvin, the ratio of magnetic susceptibility of cobalt to that of iron. First of all, we should know formula for this one. Magnetic susceptibility is some constant upon T minus T, Curie temperature. Okay, so for both of them, if you can take the ratio by substituting the respective temperatures. So for cobalt, Xc by iron, I is equal to, okay, it is inversely related to T minus Tc here. So 1600 minus, for iron it would be 1000, isn't it? So 1000 upon 1600 minus, for cobalt it is 1400. Okay, so this is going to be 600 upon 200, 0, 0, 2 ones are 2 threes. So this is going to be 3, so therefore option 3 is correct. Okay. Next, an ideal transformer has a turns ratio of 10. When the primary is connected to 220 volt 50 hertz AC source, the power output is. See, power, I mean, if you take any transformer, okay, so here power input, right, is always same as power output, assuming that it is an ideal transformer. So therefore it should be equal to the power input itself. The current in a coil changes from 2 ampere to 5 ampere in 0.3 seconds. The magnitude of EMF induced in the coil is 1 volt. The value of self-inductance of the coil is. We know that the induced EMF in an inductor is equal to L di divided by dt. So induced EMF is 1 volt and inductance is L, and the change in current di is 2 to 5. So which means that 5 minus 2, which is 3 upon the time taken is 0.3 seconds. So here that is 0.3. So L is equal to 0.3 upon 3. Okay, so this is going to be 0.1 Henry, or otherwise we can write it as this is 1 into 10 to the power of minus 1. Okay, minus 1, that you can see, or otherwise you can multiply with 100 and divide with 100. It turns out to be 100 millihenry. So option 4 is the correct answer. Next, a metallic rod of length 1 meter held along east-west direction is allowed to fall down freely. So given horizontal component of Earth's magnetic field, so the Earth's magnetic field is given 3 into the power of minus 5 Tesla. The EMF induced in the rod at an instant 2 seconds after it is. So here you need to understand that. So the east-west, I mean to say that if you take this as east and this as west and this as north and south, but this plane of east, west, north, south would be like in this particular plane, which is perpendicular to the gravity like this. Though I drew it in this particular plane here, which is in the vertical plane, but it is in the horizontal plane. So therefore the what you call rod that you have taken here, this is the kind of rod here. Let's say for example the length of the rod, I think it is given, which is 1 meter. Okay, so it is going down vertically down in the gravity direction is downwards here. Okay, so it is released from rest. So therefore velocity at any instant can be written as v is equal to u plus at, but v will become now g into t here, because acceleration is g here for us. So the induced EMF, and here it would be, because the velocity is downwards, which is perpendicular to horizontal magnetic field. Magnetic field is like this. Okay, so imagine this is what you call horizontal magnetic field, right? Then your rod would be something like this, which is going down like that. Okay, so in that case the induced EMF would be the formula which we know, BLV for us. So B is 3 into 10 to the power of minus 5, length is 1, the velocity at any instant of time is g into t. But he is asking at 2 seconds, isn't it? Substitute 2 there. So g, that is 10 into 2, which is 20. So 20 into 3 into 10 to the power of minus 5. So which is 60 into 10 to the power of minus 5. Okay, so that will be 6 into 10 to the power of minus 4. So it should be option 3. Now, a square loop of side 2 centimeters enters a magnetic field, as you can see in the figure here, with a constant speed of 2 centimeters per second. So this is 2 centimeters per second as shown in the figure. The front edge enters the field at t equal to 0 seconds. Which of the following graph correctly depicts the induced EMF in the loop? So when this side enters the magnetic field here, so there is a change of flux, obviously, because the number of lines passing through this particular area would start increasing, isn't it? So when it is increasing, according to Lenz's law, first of all we need to calculate the EMF. So the EMF would be BLV itself. Okay, so B here it is what is given, B 0.5 Tesla, which is half length. That length here it is 2 centimeters. Okay, 2 into 10 to the power of minus 2 into velocity, that is again 2 centimeter per second. So 2 into 10 to the power of minus 2 again. So 2 gets cancelled. This is going to be 2 into 10 to the power of minus 4 volts. So that is the EMF here for us. So in all the options you can see that. Okay, fine. But it should be constant, which means that only in this 3 and in this 2 you can see that, isn't it? Because this is a constant, isn't it? And here also it is constant. But for how much time? Till the what you call this entire thing stays inside the magnetic field, isn't it? Which means that this side length 2 centimeters has to go inside the magnetic field. So how much time does it take? Because it is moving with 2 centimeter per second, so the time would be distance by velocity, which is 2 by 2, that is 1 second. So till 1 second there will be induced EMF. So induced EMF, which is this one, 2 into the power minus 4, here also the same. Okay, fine. But what is the direction here? So according to Lenz's law, right, the direction should be in such a way that it should oppose the change in what you call flux here, isn't it? So the flux, magnetic flux is increasing inwards, isn't it? So we have to counter that. So the direction should be now, anti-clockwise, then only it will produce magnetic field outward, isn't it? So therefore it should be outward, and it is given that take clockwise direction as positive, so here it should be negative. So the only option I can see is a 2 here now. And you can see 5 to 6 also, there will be induced EMF. At that instant of time, this particular end starts going out, isn't it? Then the magnetic flux in this now starts decreasing. So therefore the current should be induced in the clockwise direction, then only to counter the what you call decrement in the flux. I hope it is clear. So option 2. In series LCR circuit at resonance, the phase difference between voltage and current is. First of all, in LCR circuit, we should know that the phase tan of the phase angle is equal to mod of XL minus XC upon R. And at resonance, XL will be is equal to XC. Therefore, this tan phi should be is equal to 0. Therefore, phi should be is equal to 0. So answer should be 3. An equiconvex lens made of glass of refractive index 3 by 2. So here you got a equiconvex lens, which means something like this. So you got the radius of curvature this and that as same. So both of the radii of curvatures is same here, and focal length is f. So how do we write that? 1 over f is equal to the refractive index of this medium, which is 3 by 2, or which is glass here for us, 3 by 2 minus 1 into 1 by r1 minus 1 by r2, but two of them have same radii of curvature, so it should be 2 by r for us. So here you will get 1 by 2 into 2 by r, so 2 gets cancelled, therefore focal length turns out to be the radius of curvature itself. Now what is given? It is completely immersed in water of refractive index 4 by 3. So now there is water around it, okay. So how do we calculate? Now the water with the refractive index is 4 by 3. So 1 by f dash, let's say the new focal length would be is equal to, we know the formula. The formula is refractive index of the lens upon refractive index of the medium, which is 3 by 2 upon 4 by 3 minus 1, again 2 by r, okay. So here you will get 9 by 8 minus 1 into 2 by r. So you will get 1 by 8 into 2 by r. So 2 1s are 2 4s are. So this is going to be 1 by 4r. Therefore focal length f dash turns out to be 4r. So he is asking percentage change in the focal length. So just take the difference. You will get 3r, isn't it? So which means 3r divided by the initial that is focal length, which is r, into 100. Okay, so RR gets cancelled, there is a 300% increment. So as you can see, option 2 is the correct answer.
Let's discuss question number 13 now. So it says a point object is moving at constant speed of 1 meter per second along the principal axis. So velocity of object is 1 meter per second of a convex lens of focal length 10 centimeter. Speed of image is also given to be 1 meter per second. So we all know that velocity of image is v square by u square velocity of object with respect to lens, where v is position of image, u is position of object. So what we are getting, both of them are 1, therefore we will get v must be equal to u. Now we all know that when is v equal to u? For a lens it is when u is 2f. So therefore object should be at 2f, which is 20 centimeter from the lens. So answer should be 1. Let's move to question number 14. In question number 14, they are saying that when light propagates through a given homogeneous medium, the velocities of primary wavefronts are greater than or equal to secondary wavelengths. Are they equal, or in primary wavefront it is larger, or it is in primary wavefront they are smaller? Now if you check out the question, it says about homogeneous medium. Since the medium is homogeneous, it is not changing, velocity will not change. So as a matter of fact, primary wavefront and velocities, wavelets should have equal velocity. So answer should be 2. Now let's look at question number 15. In question number 15, they are saying that total impedance of a series LCR circuit varies with omega of the AC source as shown in figure. They are asking what is the quality factor Q of the series LCR circuit. Now we all know that quality factor is omega R, which is the resonant omega, upon 2 times delta omega, which is the bandwidth. So you can see from the graph that Z becomes minimum at omega R. So omega R is 500. Also, wherever 2 times delta omega, which is the bandwidth, is where Z becomes root 2 times Z minimum. Basically, if you study NCERT also, there also this graph is there where we discuss about power becoming root 2 times. So 1 by root 2 times. So if you see, we are getting that delta 2 delta omega will be what? This value. So 2 delta omega would be 600 minus 400, which is 200. So quality factor will come out to be 500 by 200, which will become 2.5. Hence answer should be 4, 2.5. Let's move to the next question, question number 16. It says that the ratio of magnitudes of electric field to the magnetic field of an electromagnetic wave is of order of what? Now this is a very easy question from EM waves. We all have studied in EM waves that the magnitude of electric field upon amplitude of electric field upon amplitude of magnetic field is basically equal to speed of light. So that will be 10 to power 8 meter per second. So it's a factual question. So answer should be 2. Let's look at the next one. Question number 17. The question says that for a point object which of the following always produces virtual image in air. Now, because the question doesn't mention, so more appropriate question would have been if they would have said that object is real, because all of them in any particular condition may produce virtual image. But if for a real object, virtual image will be produced by convex mirror. So answer should be A or 1, convex mirror. This is a factual question. So this will be the most appropriate. So that is what you should mark, first one. Let's move to the next one. Question number 18. It says that for a given pair of transparent media, the critical angle for which color is maximum, blue, violet, green or red. Now we all know that sine of critical angle would be mu rarer by mu denser, right? Now if we take generally air, we know mu rarer would be 1 and mu denser would be like mu. Now we all know that refractive index is inversely proportional to the wavelength square. So we will get that sin C is basically proportional to wavelength square. So for the larger wavelength, we will have larger value of critical angle, larger value of sin C, and sin C being an increasing function, larger value of C. Okay. So if we increase lambda, sin C should increase, and that means C should also increase, because we are dealing with angles which from 0 to 90 where sin is increasing function. So then if we see that, so answer should be whichever has the maximum wavelength. So red has the maximum wavelength, so answer should be 4. Let's move to the next question. Question number 19th. It says that in the Rutherford's alpha scattering experiment, as the impact parameter increases, the scattering angle of the alpha particle, whether it decreases, increases, remains same or is always 90. Now, if you see what is the impact parameter is the perpendicular distance from the nucleus, and scattering angle is the angle by which alpha particle will scatter. So if you keep on increasing it, what will happen? If suppose an alpha particle goes here, it will go undeviated. So theta will be 0, whereas one which comes here, where B, impact parameter B here is large, here for this B is very small, B is almost 0, we are getting theta to be almost 180, right? If you check out NCERT, there also a graph is given between the scattering angle and the impact parameter, and we know it's inversely proportional. So therefore, as impact parameter is increased, scattering angle will decrease. So answer should be 1. Is this clear? Okay. So let's move to the next one, question number 20. It says that 3 energy levels of hydrogen atom and the corresponding wavelength of the emitted radiation due to different electron transition are as shown. So then they have given that as in a hydrogen atom, as electron transits from n equal to 3 to n equal to 2 and n equal to 1, it can, if it goes from 3 to 2, it emits lambda 3, if it goes from 3 to 1, lambda 2, and 2 to 1, it emits lambda 1. They are asking what is the relation between them. Now what we all know is that E3 minus E1 will be equal to E3 minus E2 plus E2 minus E1, right? So now if I put E3 minus E1 would be what? It should be equal to the energy of the photon which is emitted, right? So E3 minus E1 will become Hc by lambda 2. Now E3 minus E2 will become Hc by lambda 3 and E2 minus E1 will become Hc by lambda 1. So we can see that Hc gets cancelled and we are getting 1 by lambda 2 is 1 by lambda 3 plus 1 by lambda 1. Therefore, lambda 2 will come out to be from this lambda 1 lambda 3 divided by lambda 1 plus lambda 3. So if lambda 2 is lambda 1 lambda 3 upon lambda 1 plus lambda 3, it matches with option number 2. So answer should be 2. Lambda 2 is lambda 1 lambda 3 lambda 1 plus lambda 3. Let's move to the next one, question number 21. It says that an unpolarized light of intensity I is passed through 2 polarites kept one after the other with their planes parallel to each other. The intensity of the light emerging from the second polarite is I by 4. So the angle between the pass axis of the polarite is what? 60 degree, 30 degree, 45 degree or 0 degree. Now if you see there are 2 polarites, because here we have an unpolarized light, we know that when after passing to the first polarizer, intensity becomes half. So here intensity will become I naught by 2. Then if suppose the pass axis of the second polarizer makes an angle theta with the pass axis of the first polarizer, then just a minute. Yeah. Then what happens? Then what we find is that intensity, we know the formula that I is I naught cos square theta. So we will put I naught as I naught by 2 and theta is what we have to find out. This is law of Malus. So I is given as I naught by 4, or they have given I naught as I, so I will become I by 4 or I naught by 4. So we will get that half is cos square theta. So therefore cos theta is 1 by root 2 and hence theta must be 45 degrees. Hence answer should be 3, 45 degrees. Let's move to the next one, question number 22. Now it says that in the Young's double slit experiment, the intensity of light passing through each of the 2 double slits is this. So both the light sources, which are 2 slits which are acting as the secondary sources of light, have intensity 2 into 10 to the power minus 2 watt per meter square. So this we can write as I naught, which is 2 into 10 to the power minus 2. Okay. Now the screen slit distance is very large in comparison with slit distance. The fringe width is beta. Now we know fringe width beta is lambda d by small d. They are saying that the distance between central maximum and a point where x is beta by 3, then what is intensity at that point. So what they are asking is, wherever x becomes beta by 3, if we go from the center of the screen at a distance of beta by 3, what is the intensity here? That is what the question is asking, right. So we all know that we have to find, we know that intensity at any point is what? It is 4 I naught cos square phi by 2, where I naught is intensity of each slit which is given. Also, what is phi? Phi is the phase difference at that point. When the two waves reach that point, whatever is the phase difference, that is what is phi. So, if we look at, we have to first find out what is the phase difference at that point. Now, we all know that phase difference is 2 pi by lambda into delta x, right. Now, if we see what is delta x for a YDSC is given by d sin theta, which is approximate to d tan theta, which becomes dy by capital D, right. Now, they have given that we know that beta is lambda capital D by small d. From here we get 2 pi by beta, and they have given y to be beta by 3. From the central slit we are going at a distance beta by 3. So, we get that phi there is 2 pi by 3. So, if I put it in this formula, we will get intensity as 4 I naught cos square 2 pi by 3 by 2. So, it will become cos square pi by 3, right, which is basically, it will come out to be what, 4 I naught into half ka square. So, which will 4 and 1 by 4 will go off. So, we will get answer as I naught, which is this itself. So, answer will be 1. Let us move to the next one. It says that a 60 watt source emits monochromatic light of wavelength 662.5 nanometer. The number of photons emitted per second are how many? Now, if we see, many of us know this formula, that number of photons emitted per second is given by P lambda by Hc, where P is the power of the source, lambda is the wavelength, and H and C are Planck's constant and speed of light. Even if you do not know this formula, you can figure it out within a minute, that suppose there are, if one photon gets emitted, energy which is being emitted is Hc by lambda, right. Now, if n photons get emitted per unit time, we should have n into Hc by lambda per second, that will become energy per unit time, which is the power, right. So, we will get n as P lambda by Hc, which I initially only told you. Now, we have to just put in the values and we will get the answer. So, P is 60 watt, lambda is given to be 662.5 into 10 to the power minus 9, H is 6.63 into 10 to the power minus 34, and C is 3 into 10 to the power 8. Now, if you see, you can easily cancel these out, and if we just solve this, you will get answer as 2 into 10 to the power 20. So, answer should be 4, 2 into 10 to the power 20. Let us move to the next one. It says that in an experiment to study photoelectric effect, the observed variation of stopping potential with frequency of incident radiation is as shown in the figure. They are asking what is the slope and y-intercept of this particular graph. Now, we all know that what is stopping potential? Stopping potential is H into frequency minus phi, which is the work function of the metal, divided by E, right. Now, we can also write work function as H into the threshold frequency. So, what do we get V naught as? We get H by E into nu minus H nu naught by E. Now, because it is a clearly straight line equation, what we can see is that it can be compared to y equal to mx plus c, where m being the slope, c being the y-intercept. So, one can clearly see V naught is along along y-axis, frequency is along x-axis. So, slope will become h by e. So, slope should be h by e, which is only in 3. We can also confirm that y-intercept c is minus h nu naught by e, which is also there in 3. So, answer should be 3.
Hello students, now we will discuss question number 25. So, the question is, a full wave rectifier is there having two diodes D1 and D2, and the frequency is given as 50 Hz. Now, the question is, how many times the first diode will conduct? Okay. So, as we know, what is frequency? Frequency is how many times a cycle is repeated in 1 second. Okay. So, if you see a full wave rectifier, in that both the diodes will work for half of the time in each of the cycle, right? Each of the cycle, both the diodes will work. Okay. First for positive, then for negative. Okay. So, every diode, both diodes will be working for equal time, so it will be 50 times only in 1 second. If the frequency is 50 Hz, so both the diodes will work for 50 times in 1 second. I hope this is clear. Very simple question it is. Next question is, this is a diagram given to you. Okay, you have to select its correct truth table. Okay, now this is A and this is what? B. This gate is NOR gate. So what will be the output for this? It will be A plus B complement, right? That will be equal to A complement into B complement. And here, what is the input? This is A, this is B. So here it is AB. Now, this is your NAND gate. So what is your output? Whole complement. As we know that if we take A complement into A, that is equal to what? 0. Therefore, this is what? 0. And the complement of 0 is what? 1. A into A complement will be 0. B into B complement is what? 0. So complement of 0 is what? 1. So the answer is what? 1. No matter what is the value of A and B, always the output is going to be 1 only. Therefore, the correct answer is option 1 over here. I hope it is clear for everyone. Moving to the next question. The next question is, the energy gap in an LED is given as what? 2.4 electron volt. Okay, you have to find out the momentum of the emitted photons. So how we will find the momentum of the emitted photons? Energy is how much given here? 2.4 electron volt. Okay, if we convert into joules, it can be written as 2.4 into 1.6 into 10 to the power minus 19. Now, this energy we can equate to hc by lambda, right? So from here, what is h by lambda? H by lambda will be 2.4 into 1.6 into 10 power minus 19 by c. C being the speed of light, so that is 3 into 10 to the power 8. And this h by lambda we also call as what? Momentum. Simplifying this, what we will get is 1.28 into 10 to the power minus 27. So the correct answer for this would be option 3. I hope it is clear for everyone. Moving to the next question. Here beta decay is happening. Okay. Now the question is, find the number of neutrons in the nucleus of X. Alright. So here if you see, in beta decay, what happens basically? In beta decay, one neutron is converted into one proton and a beta particle, right? So if it is converted into one proton, so what will be the number over here? You can say it will be 83 plus 1, okay, atomic number you can say. Then this would remain same, because anyhow this is what? Total number of nucleons. Okay, means number of neutrons plus number of protons. Number of nucleons would remain same. So this is what? 84, right? So number of nucleons remains the same. Number of nucleons is 210 and number of protons is 84. So what is the number of neutron? It will be 210 minus 84. Okay, this would come out to be equal to how much? 126. So the correct answer for this is option 3. Again, it's a very simple question. Moving to the next question. Now in this question, initially the nucleus has mass number 220. Okay, it is emitting an alpha particle. Okay, so basically what will happen? Total energy in this is given as how much? 5.5 mega electron volt. That total energy will get divided in two parts. That will be the kinetic energy of alpha particle and the kinetic energy of the decayed particle, right? Now, since initially it was at rest, initially its momentum is what? 0. So the final momentum should also remain 0 only. So we can say that if the alpha particle moved in this direction and the remaining decayed particle moved in this direction. So you can say that their momentum would have the same magnitude. So momentum of this alpha would be equals to momentum of this decayed particle, right? Momentum of alpha is equals to momentum of the decayed particle. So momentum of alpha square would be equal to momentum of the decayed particle square. Now you know the relationship between kinetic energy and the momentum. Okay, what is the relationship between them? Momentum square we can write as 2 times of, like if you see here, momentum is mass into velocity and kinetic energy is half mv square. So if we multiply mass and divide by mass, so we can say that this is p square by 2m. Alright, therefore we can say that p square is what? 2 times of mass into kinetic energy, right? So we can say over here in this case that 2 times of mass of alpha particle multiplied by kinetic energy of alpha particle would be equals to 2 times of mass of the decayed particle multiplied by kinetic energy of the decayed particle. Okay, so from here we can say that mass of alpha particle is what? You can say 4, alright. And what is the mass of the decayed particle? Total was 220. So what is the mass of decayed particle? You can say 220 minus of 4, that is 216. So it can be written as 216 kinetic energy of the decayed particle, right? So from here one relationship will get that kinetic energy of the decayed particle will be equals to 4 times of kinetic energy of the alpha particle by 216, right? This is equals to, if you simplify it, it will come out to be 54. Now we can put this in this expression over here. So we can say 5.5 will be equals to kinetic energy of the alpha particle plus kinetic energy of the decayed particle. So this will be 55 times kinetic energy of the alpha particle by 54, and that is equal to 5.5. Simplifying this, kinetic energy of the alpha particle would come out to be 5.4. So the correct answer in this case is what? 5.4 mega electron volt. I hope you have understood this question, right? Moving to the next question. There is a radioactive sample that has got half-life 3 years. Now the question is how much time will be required to reduce its activity to 1/5 of its initial value, right? So how we'll find out? Okay, so initially let us say it is A naught. In half-life, in 3 years it will become A naught by 2. In the next 3 years it will become A naught by 2, that is A naught by 4. In the next 3 years it will become A naught by 4 by 2, that is A naught by 8. Now here it should reduce to 1/5. In 9 years it is reducing to 1/8, alright, and in 6 years it is reducing to 1/4, right. So 1/5 will be between 6 years and 9 years. So only one option is over here, that is 7 years, so we can choose it and that will be our correct answer. So 7 years is the correct answer in this case. Moving to the next question. Now you have a p-n junction diode that is in forward bias. Okay, which type of charge carrier flows in connecting wire? So when p-n junction diode is in forward bias, the majority carrier is the free electrons only. Okay, this is a theoretical question. The correct answer is free electrons. Okay, it's a very simple question. Moving to the next question. Question number 32. In this case, a ball of 0.2 kg is thrown vertically down from a height of 10 meter. Okay, so from a height of 10 meter, a ball has been thrown vertically down. Let us say the initial speed is what? V. Okay, now it will hit the ground. What will be the total energy when it is hitting the ground, total energy when it is hitting the ground will be the loss of potential energy plus the initial kinetic energy. So total energy over here will be mgh. How much is the height it has come down? 10 meter, right? So mgh plus half of mv square. This half mv square is the initial kinetic energy and mgh is the loss of potential energy. So the total energy just before hitting the ground is mgh plus half mv square. Now they say that after hitting the ground it loses half of its energy, right? If it has lost half of its energy, how much energy is left? mgh plus half mv square by 2. This much energy is left. And then they say that it goes up to the same height, means it is going up to the same height h, means the kinetic energy just after this collision is equal to the potential energy required to go up to the height. So that it will be equal to, you can say, simply mgh, because at the top what will be its again kinetic energy? 0. Kinetic energy will be what? 0. Simple we can say. See here, initially the total energy is mgh plus half mv square. It has lost half of its energy, right? And that is equal to mgh. That is equal to mgh because it is going up to h height. So if we simplify this, half mv square will be equal to mgh. So from here v will come out to be root of 2gh, right? G we can take as 9.8 and from how much height has come down? 10. Simplifying this, it will come out to be root of 196. Okay, so your answer is 14. So the correct answer for this is 14 meter per second. Again, a very simple question from the kinematics chapter. Moving to the next question. The question is, the moment of inertia of a rigid body about an axis is depending upon which factors? See, moment of inertia, if you see, is what? It depends upon the position of axis of rotation. So here the correct answer is 1. Okay. The other options, if you see, it does not depend upon the size. Of course, it depends upon the size. Okay. The other option is does not depend upon the mass. Yes, it depends upon the mass. Okay. And the next option is does not depend upon its shape. It depends upon shape. It depends upon all these factors. Okay. And it depends upon the position also, position of the axis of rotation also. So here the correct answer is option 1. Okay, this is a theoretical question, a very simple question. Moving to the next question, here we got to find out the total moment of inertia of this system about this particular point. What is given over here? There are, you can say, total 7 identical discs, right? And we have to find out moment of inertia about an axis that is perpendicular to the plane of this disc, okay, plane of this disc, okay, and passing through the center of this middle disc, right? So how we will find out? Moment of inertia will be moment of inertia of all the disc about this particular axis. All right, the radius of each disc is given as what? R, right? For this particular disc, what is the moment of inertia about this axis? It will be simple, mr square by 2, right? Now, what is the moment of inertia of this disc? We can apply parallel axis theorem for that. Moment of inertia of this disc about this axis will be what? It is going to be mr square by 2. But we have to find about this particular point. What is the distance of this point from this? It is 2r. So it will be m into 2r square. Okay, so the moment of inertia of one of this disc about this axis is mr square by 2 plus m into 2r square, right? Now, how many such discs are there? 1, 2, 3, 4, 5, 6. So we can simply multiply 6 in this, all right, and add all of them. Okay, adding all of them, and if we simplify, it will come out to be what? If we add and simplify, it will come out to be 55 mr square by 2. So the correct answer is option 1. Very simple. Moving to the next question. The next question is, The next question is, the true length of a wire is given as 3.678, right? And we are using instrument A. With the instrument A, the length of the wire comes out to be what? 3.5 centimeter. And with the instrument B, the length of the wire comes out to be what? 3.38 centimeter. So you have to say which instrument is more precise and which instrument is more accurate. So the true value is 3.678 centimeter. This is your true value, right? Now, if you see, the reading of the first instrument is 3.5 centimeter and the second instrument is what? 3.38 centimeter. Since the reading of the first instrument is closer to the true value, therefore instrument A is more accurate. Now if you see in the instrument B reading, how many decimal places you are having? 2 decimal places. And in the instrument A reading, how many decimal places you are having? 1 decimal place. As we know, if the number of decimal places are more, it is more precise. Therefore, we can clearly say that instrument B is more precise because it has more number of decimal places, right? So here the correct answer would be option D. Measurement with A is more accurate while the measurement with B is more precise. A very simple question. Moving to the next question. The next question is, a body is moving in a straight line with initial velocity v0 and its acceleration is given as what? Constant. Okay. After t seconds, its velocity becomes v. The question is, what is the average velocity of this body over the time interval? Okay, so it's a very simple question. We know what is average velocity. Average velocity is net displacement by the total time taken. Average velocity is what? The net displacement by the total time taken. Now, since the acceleration is constant, we can use this expression v square equals to v0 square plus 2a into displacement. So what is the net displacement from here? V square minus v0 square by 2a. Now this displacement we can put over here. So v square minus v0 square by 2a and then divide by time, we will get the average velocity. So the correct answer in this will be option 2.
So next question is question number 37. A particle is in uniform circular motion related to one complete revolution of the particle. Which among the statement is incorrect? So as the question is what? Asking the incorrect statement. So they are telling that the particle has taken the one round of the circular motion and it's a uniform circular motion. So the options are, average speed of the particle is 0. So average speed of the particle will be what? Let's suppose the radius is r, okay, and it has taken the distance how much? 2 pi r, and it will take some time also, okay. So this average speed can never be 0, okay. So option 1 is what? Incorrect, because they are asked the incorrect option. So let's check the other options also. Average velocity of the particle is 0. Average velocity of particle is 0 only. Why? Because when the particle starts from this position and ends up here, displacement is 0. So that's why the average velocity is 0. So this statement is correct. Average acceleration of the particle is 0. Since the particle started here, the acceleration direction is what? Towards the center, and when it comes back and again the same acceleration will be there, so that change in acceleration for the whole revolution is what? 0. So therefore average acceleration will also be 0. So that is correct. Displacement of the particle is 0. Now displacement of the particle is what? 0 only, because starting point and the end point is same. So that is also correct. So option 1 is incorrect. So that is the answer. Next, question number 38. A body of mass 10 kg is kept on a horizontal surface. The coefficient of kinetic friction between the body and the surface is 0.5. So according to the question, we draw the diagram. So let's suppose there is a body of mass 10 kg placed on the surface where the coefficient of friction is mu is 0.5. 0.5 is the coefficient of friction. A horizontal force of 60 Newton is applied. So 60 Newton force is applied horizontally on the body. So they are asking the resulting acceleration. So this force is what you have to check, that is this force is greater than F limiting to slide the body, okay. So first for that we have to find the F limiting. So F limiting we have to find first, that is what? Mu n. And here since the body is capped on the flat surface, on the horizontal surface, a normal and mg will be equal. So n will be equals to mg. So mu is 0.5 into mg. Mass is what?
10 kg. So what we write here? 10 G. So it will become this become 5 G Newton. 5 G Newton, if I take G is 10, it will be 50 Newton force. So since the applied force is greater than that, so this body will slide. Now here, since the mu is given 0.5, so mu s and mu k are same only. So when it slides, okay, when it is slides, friction become kinetic, and kinetic friction value is same as the limiting friction value, so it will be 50. So when it is what sliding, okay, the net force on the body is 60 minus 50. So acceleration is defined as net force. So net force is 60 minus 50 by mass. Mass is 10 kg. So answer is 1 meter per second square. So that is what the answer for this question. So option 3 is correct. Next question. Now this is a PV diagram. Question number 39. The PV diagram of a Carnot engine is shown in the graph below. The engine uses 1 mole of an ideal gas. So number of moles are what? 1. A gas as a working substance. From the graph, the area enclosed by the PV diagram is. So they are asking about the area enclosed in this PV curve. So what is the meaning of area enclosed in the PV curve in the closed cycle? Is the net work done in that cycle. So here A to B process is what? Isothermal. B to C process is what? Adiabatic expansion. C to D process is what? Isothermal compression. D to A process is what? The adiabatic compression. So if I just see these two isotherms, so let's suppose the temperature here is what? T1. Here the temperature is what? T2, because these are what? Isotherms. Now if we just follow the efficiency formula of the Carnot cycle, then it is what? 1 minus T2 by T1. That is what the formula here. So 1 minus, now T2 is the temperature between any point C to D. So let's, because at the point C I know the pressure and the volume, so I will use the formula PV is equals to nRT. So PV we know, okay, so we can write in terms of what? Since nR is same, okay, so we can write here what? The pressure at the point C and the volume at the point C. So we can write here pressure at C, volume at C divided by, now since at point A pressure and volume are given, we can write for T1, so pressure at A, volume at A. Now this is what the relation for the efficiency we will get here. Now what is efficiency? Efficiency is defined as what? Work done by heat input. Okay, so this is 1 minus. Now we can place the value of pressure at point C. So pressure at point C is what? 400. You just check the unit here. It is what? Kilopascal. So 400 into 10 raised to power 5. And the volume at the point C is 6.25 centimeter cube. So you have to write in the SI unit. So 6.25 into 10 raised to power minus 6. I had converted into meter cube. Divided by PA into VA. So divided by PA into VA. What is the pressure at point A? 1600. So 1600 into 10 raised to power 5. 10 raised to power 5. 1 minute. So next question is question number 39. So the PV diagram of a Carnot engine is shown in the graph below. The engine uses 1 mole of an ideal gas as working substance. From the graph, the area enclosed by the PV diagram is. So they are asking what is the work done in the whole cycle. This work done they had asked, okay. Now for this process is what? A to B is what? Isothermal. C to D is also isothermal. Let the temperature in the isotherm A to B is T1 and C to D it is what? T2. These are isotherms. Now we talk about the efficiency formula of the Carnot cycle. So efficiency is 1 minus T2 by T1. Now since we don't know the temperatures T1 and T2, but we know at the T1 for the curve A to B, at the point A we know the pressure and we know the volume. Similarly at point C we know the pressure and we know the volume. So by using the relation PV is equals to nRT, because since the temperature is what, like N and R are same for both the for whole gas, okay. 1 minute. Our next question is question number 39. The PV diagram of a Carnot engine is shown in the graph below. The engine uses 1 mole of an ideal gas as a working substance. From the graph, the area enclosed by the PV diagram is. So they are asking the work done by the gas, okay, means what they are asking this area. So this is actually what the net work done. So if we follow the efficiency of the Carnot cycle, it is defined as 1 minus T2 by T1. So let's suppose this isotherm had the temperature T1 and this isotherm has the temperature what? T2. So the formula is 1 minus T2 by T1. So the temperature T2 can be written as what? Pressure into volume by NR. So pressure at point C, volume at point C. So PV, pressure at point C, volume at point C divided by NR divided by pressure at point A, volume at point A divided by NR. Since N and R is a what common, so you can cancel out here, okay. Now here we can place the value and we will put the definition of efficiency. Efficiency is what actually work done by heat input. So Q input, and here we got 1 minus, what is the pressure at point C? Pressure at point C is 400 kilopascal. So we can write here 4 into 10 raised to power 5. And volume at point C is what? 6.25 into 10 raised to power minus 6, because it is given in centimeter cube, so you have to place in what? Meter cube, divided by pressure at point A is 1600. So 1600 into 10 raised to power 3 per kilopascal it is, and volume is 2.5. So 2.5 into 10 raised to power minus 6. Okay. After solving this equation, Q input is given in the question. Q input, heat supplied to the gas is Q input, that is 8000. 8000. Okay. Now when you solve this, okay, you will get work done as 3000 joules. So that is actually what the area under this cyclic process. So answer is option 1. Okay. Next question is question number 40. When a planet revolves around the sun in general for the planet. So they are asking about the Kepler's. This question is from the Kepler's planetary motion. So first option is what? Kinetic energy and potential energy of the planets are constant. No. If we just follow if let's suppose this is the sun and this is what the elliptical orbit, because it is not necessary that orbit will always be circular. General orbit is actually what? Elliptical. So when the planet is closer, potential energy is what? Less. When the planet is far away, potential energy is more. When the planet is closer, kinetic energy is what? More. When it is far away, kinetic energy is what? Less. So the potential energy and kinetic energies are not constant in the planetary motions, okay, but summation of total energy is a constant. So they are asking, when a planet revolves around the sun in general for the planet, kinetic and potential energy of the planets are constant. So this is wrong. Okay. Next, angular momentum about the sun and aerial velocity of the planet are constant. See, this is according to the Kepler's second law. Okay, Kepler's second law says that the aerial velocity will for a planet will always be what? A constant. So aerial velocity represents actually the angular momentum. So angular momentum of a planet will always be constant about the sun. Next, linear momentum and linear velocity are constant. No, velocity is changing at every moment in the elliptical path. So that is what? Also wrong. Linear momentum and aerial velocities are constant. See, aerial velocity is a constant, but linear momentum is a variable, okay, because speed is a variable or velocity is a variable. So this is also wrong. So option 2 is correct. So next question is question number 41. A stretched wire of a material whose Young's modulus is what? Y 2 into 10 raised to power 2 into 10 raised to power 11 has Poisson ratio 0.25. Its lateral strain is 10 raised to power minus 3. Okay. So first of all, we should know the formula of the Poisson ratio. So Poisson ratio is defined as what? Lateral strain by longitudinal strain. Okay. So lateral strain is given here is what? 10 raised to power minus 3. And longitudinal strain, I am assuming, let's suppose x. So sigma is given as what? 0.25. So what is the value of x here is what? 4 into 10 raised to power minus 3. That is actually what? The longitudinal strain. Now they are asked in the question, what is being asked? The elastic energy density of the wire is. So elastic energy density is defined as what? Half y into strain square. This is the formula we can directly use, y into strain. Now this strain is actually what? The longitudinal strain. So here just place the values. Half, what is the value of y? 2 into 10 raised to power 11 into strain square. Strain is what? 4 into 10 raised to power minus 3. Okay, whole square. So the answer will come out to be 16 into 10 raised to power 5 joule per meter cube. That is the answer for the question number 41. Next question is question number 42. A closed water tank has cross-sectional area A. So this area, the top area is A. It has a small hole at a depth of H. Okay, so there is a hole at the depth H is given in the figure from the free surface. Okay, the radius of the hole is R. So its radius is R, so diameter is 2R. So that R is very, very less than under root A by pi. So this hole is very, very small in comparison to this area of cross section. If P naught is the pressure inside the tank above the water level, so here the pressure just above this is what? P naught, and PA is the atmospheric pressure. So pressure here on the orifice is what? PA, because it is open to atmosphere, so it is what? PA. The rate of flow of water coming out of the hole is. So here we will apply what? We will apply the Bernoulli relation between this point and this point. So let's suppose here the velocity of efflux is what? VE. Now since this area of cross section is very large, we will consider this velocity almost zero. So let's apply the Bernoulli relation. So what is the pressure at this point? Pressure at this point is what? P naught. Velocity of this point is 0, so half rho v square will be 0. Now we are taking the orifice as the reference for the Bernoulli equation. So our next energy is what? The potential energy per unit volume. That formula is what? Rho g h. Okay. Now next we have to write for the RHS for this point. At this point pressure is what? PA. The velocity is what? VE. So the kinetic energy per unit volume will be half rho VE square plus, since this point is at the reference, so no potential energy. Okay. Now if we solve this equation, we will get the velocity of efflux. So after getting the velocity of efflux here, we can write the rate of flow. So rate of flow is defined as area of cross section of orifice. So the area of cross section of orifice is what? Pi r square into velocity of efflux. Okay, so find the value of velocity of efflux from the first equation, place it here, you will get the answer, and the answer will be this option 4, pi r square under root 2gh 2 p naught minus pa by rho. Okay, next question is question number 43. 100 gram of ice at 0 degree Celsius is mixed with 100 gram of water at 100 degree Celsius. The final temperature of the mixture is. So this question is from the calorimetry. Latent heat of fusion of ice is given and the specific heat of water is given in the SI unit. So you have to find the final temperature of the mixture when we mix. So here 100 gram of ice at 0 degree Celsius is mixed with 100 gram of water at 100 degree Celsius. So you have to see either the ice is dominant, is the water is able to melt the ice completely. So Q1 is the heat. Let's suppose Q1 is what heat? The heat required to melt the ice completely. So that will be mass into latent heat of fusion. So if I just write the latent heat of fusion in calories, because we can work in calorie. So latent heat of fusion in calorie is what? 80 calorie per gram. Because since the masses are given in gram, so we can use these units instead of these units. Okay, there is not a issue in that. Okay, so Q1 equals to mass into LF. Here this mass is mass of ice. So mass of ice is 100 and latent heat of fusion is what? 80. So it is about how many calories are required? 8000 calories are required to melt the ice. Now who will give this heat? Water will give the heat. Water is at 100 degree Celsius. So let's suppose all the water moves from 100 degree Celsius temperature to 0 degree Celsius. Then how much amount of heat will be released by the water? So that is what my heat Q2. So Q2 is the heat released by the water if its temperature changes from 100 to 0. So we will use here the specific heat capacity formula. Okay. So MS delta theta. What is the mass of water here? 100 gram. And what is the specific heat capacity of water? Specific heat capacity of water in terms of calorie is 1 calorie per gram per degree Celsius. That is the formula. So MS delta theta, so mass is 100 gram, S is 1 in calorie, okay, and delta theta is 100. So it is coming out to be 10,000 calories. So it is clearly observed that the Q2 is greater than Q1 means what? Water will give the 8000 calorie to the ice and ice will get completely melt. Now after melting the ice, as the ice get completely melt, it will becomes what? The 100 gram water. 100 gram water at 0 degree Celsius. And after giving the 8000 calorie, the water will come at what temperature? So let the temperature of the water becomes what? Theta. So we will use here the formula Q is equals to ms delta theta. Okay, so Q is what? How much heat is taken by the ice from the water to become 100 gram water at 0 degree Celsius. So that is 8000. So put Q as what? 8000 here. Okay, mass we have to find. Mass is given as what? 100 gram for water. Okay, so we can place here what? Mass as 100. Next question is question number 43. 100 gram of ice at 0 degree Celsius. Next question is question number 43. 100 gram of ice at 0 degree Celsius is mixed with 100 gram of water at 100 degree Celsius. The final temperature of the mixture is, they were asking, okay. So here the latent heat of fusion and specific heat of water is given. So, but we write in calories. So latent heat of fusion in calories is 80 calorie per gram. And if I write the specific heat of water in calories, so it is 1 calorie per gram per degree Celsius. Okay. Now you have to check the dominancy of ice and water. So for example, let's suppose if I require to melt the ice, 100 gram of ice at 0 degree Celsius to 100 gram of water, 100 gram of water at 0 degree Celsius, then how much amount of heat is required to melt the ice? So that is what? M into latent heat of fusion, where M is the mass of ice. So 100 into 80. So it is what? 8000 calories. So 8000 calories amount of heat is required to melt the ice. Similarly, if the water, let's suppose at 100 gram of water at 100 degree Celsius is what? Its temperature is lowered and it will be comes from 100 degree Celsius to 0 degree Celsius, then how much amount of heat it will release? So that heat I am assuming is what? Q2. So we will use the formula of specific heat capacity, ms delta theta. What is the mass of water here? 100. And what is the specific heat capacity? 1. And what is the drop in temperature? 100. So it is how much? 10,000 calories. 10,000 calories. Okay. So here it is clearly observed that Q2 is greater than Q1. So since Q2 is greater than Q1, so Q2 easily gives the 8000 calorie and all the ice will what? Melted. Okay. So when all the ice get melted after giving 8000 calorie, what will be the temperature of water? That we have to find. So we will use this formula Q is equals to ms delta theta. Okay. So where Q is the heat given by the water. So the water has given how much amount of heat to melt the ice? 8000. Okay. What is the mass of water here? 100. What is the specific heat of water is what? 1. Now delta theta we have to find. So delta theta will be 100 minus theta. Here we have to write what? The drop in temperature. What is the drop in temperature happens? That is what? 100 minus theta. So when you solve this equation, what do we get here? 100 got cancelled out. So 80 equals to 100 minus theta. So theta will come out to be 20 degree Celsius. Now the situation is this, that there is 100 gram of water at 0 degree Celsius. This water has come from where? From ice, and 100 gram of water at 20 degree Celsius. Okay. So if the both are in the same state, both are water only, and the temperatures are 0 and 20 and masses are also same. So the equilibrium temperature or final temperature will be in between because the masses are same. So final temperature will be 10 degree Celsius. No need to apply the equation, directly we can write because this is a fact, because masses are same and state is same. So final temperature will be what? Average of these two temperature, that is what? 0 plus 20 by 2. So answer will be 10 degree Celsius. So option 4 is correct. Okay, next question is question number 44. In the situation shown in the figure, magnitude of Q is very, very less than capital Q and R is very, very greater than capital A. I think this is what the R they were trying to tell, and this is what the A. The net force on the free charge minus Q and net torque on it about O at the instant shown are respectively, where P is actually the magnetic, dipole moment of this dipole. That is what? Charge into length of the dipole. So they are asking the force here. So what is the, because this line is an equatorial line, the field here it will be what? What is the dipole direction? Next question is question number 44. In the situation shown in the diagram, magnitude of Q is very, very less than capital Q mod and R is very, very greater than A. The net force on the free charge minus Q, free charge is placed minus Q and net torque on it about O. This point is O. Next question is question number 44. In the situation shown in the diagram, magnitude of Q is very, very less than capital Q and R is very, very greater than A. The net force on the free charge is minus Q. The next question is question number 44. In the situation shown in the diagram, magnitude of Q is very, very less than capital Q. R is very, very greater than A. The net force on the free charge minus Q and net torque on it about O. So this point is O. At the instant shown are respectively, where dipole moment is what? 2aq. Now what is the direction of dipole moment? Always negative to positive. So this is the direction of dipole moment. Now this point P is on the equatorial line, so direction of field will always be opposite to direction of dipole moment. So this is the direction of field. Now since the charge is negative, so the direction of force will be what? Opposite to direction of field. So this is the direction of force and this direction is actually what? X-axis. So this is direction is what? Along the I cap. Now what is the field at the equatorial axis? The field at the equatorial axis formula is what? Kp by r cube. In the condition when R is very, very greater than A. So what will be the force here? The force will be charge into field. So it will be K cube P by R cube is the force and direction is what? I cap, because as we have seen here, field direction is this, so force will be opposite because charge is negative. So this is what the direction. K is 1 upon 4 pi epsilon naught. So what are the option in which the positive I cap is given? This option and this option, and here also it is Kp cube by R cube. This is also Kp cube by R cube. So these are the two options which are correct. So means what? Option 1 and option 4 are what? Incorrect options. Okay. Now let's check about the torque. Now torque about O we have to see. So R, what is the formula of torque? R cross F. So R cross F if we apply, so direction of torque is coming inside the plane. So it should be minus K cap. So in one option only the minus K cap is given. So this is the correct answer, option 3. Next question is question number 45. Pressure of ideal gas at constant volume is proportional to. So they are asking the next question is question number 45. Pressure of ideal gas at constant volume is proportional to. So if we follow the ideal gas equation, PV is equals to nRT. So they are telling that volume we are considering constant. So pressure is actually directly proportional to nRT. Now this nRT is actually, if we just see the total internal energy of the gas, internal energy of the gas formula is NCVT, where CV is what? FR by 2. So here we can say that nRT can be replaced by what? By the U. Okay, so we can say that pressure is what? Directly proportional to internal energy, and internal energy is actually what? The total kinetic energy of the gas. So which option is correct? This option is correct. That is actually the total energy of the gas. A block of mass m is connected to a light spring of force constant K. Next question is question number 46. A block of mass m is connected to a light spring of force constant k. The system is placed inside a damping medium of damping constant b. The instantaneous values of displacement, acceleration and energy of the blocks are x, a and e respectively. The initial amplitude of oscillation is what? Capital A, and omega dash is the angular frequency of oscillation. The incorrect expression related to the damped oscillation. So this question is on the basis of damped oscillation. Directly here we have to identify which equation is what? Incorrect. So if we just write the displacement equation of the damped oscillation, that is what? X is equals to a e raised to power minus bt by 2m cos omega dash t plus 5. Here we had taken cos because in the question it is what clearly mentioned, it is starting from the amplitude position. So if we start from amplitude position, we have to take here what? Cos here. So cos omega dash t plus phi is what? The general equation of the displacement with time. Now if we compare this with what? The equation number 3, this equation is wrong. Why? Because here it is given as minus b by m. Because here it should be minus bt by 2m, then it is what? Correct. So this option is wrong option. Next question is question number 47. The speed of sound in an ideal gas at given temperature T is V. So what is the formula of the speed of sound? The speed of sound formula is under root gamma r T by m. Okay, where gamma is what? The adiabatic constant, T is temperature, m is the molecular mass in kg. Okay, the RMS speed of a gas molecule at that temperature is Vrms. So let's write the formula for the Vrms. So Vrms formula is under root 3RT by m. This is the formula for the Vrms. The ratio of the velocities V and Vrms for helium and oxygen gases are x and x dash. So they are taking the ratio of V and Vrms. So this is what we are taking the ratio here. So when we take the ratio RT by m will get cancelled out. It will come out to be under root gamma by 3. Next question is question number 47. The speed of sound in an ideal gas at a given temperature T is V. The RMS speed of gas molecule at that temperature is Vrms. The ratio of the velocities V and Vrms for helium and oxygen are x and x dash respectively. Then they are asking the ratio of x by x dash. So first, what is the formula of speed of sound? That is what V is equals to gamma r T by m, where gamma is the adiabatic constant, T is temperature, m is the molecular mass. Similarly, what is the formula of Vrms? Vrms formula is under root 3RT by m. Now they are telling the ratio of the velocities we had taken. That is what? So ratio of the velocity is what? V by Vrms they had taken. So if I divide these two equations, RT by m will get cancelled out. We will get here gamma by 3. Now this ratio for the, first we have to write for the X. X is for the helium gas. Now helium gas is monoatomic. For the monoatomic, gamma value is what? 5 by 3. So what we will get here? 5 by 3 by 3. So it is what? Under root 5 by 9. That is what the value of X. Similarly, we find the value of X dash, that is for oxygen. Oxygen is a diatomic gas. For diatomic, gamma value is what? 7 by 5. So we will place the value here. 7 by 5 divided by 3. So we will get here under root 7 by 15. Now they are asking the ratio of X by X dash. So X by X dash we have to find. So what is the value of X? Under root 5 by 9. And what is the value of X dash? The value of X dash is 7 by 15. So when we solve this, the answer will come out to be 5 by root 21. So which option is correct? Option 4 is correct. Next question is question number 48. A positively charged glass rod is brought near to uncharged metal sphere which is mounted on an insulated stand. If the glass rod is removed, the net charge on the metal sphere is. So there is a metal sphere that is what? Placed on the insulated stand. and the charged rod is what? Brought near to it, okay? So let's suppose this charge is positively charged rod, okay? Then what will happen here? Polarization will happen here. Minus charge will come here, positive charge will come here, okay? Now as you remove the rod from here, this polarization will not be there, and then it will remain, because previously also it is what? Neutral. In the question it is written a positively charged glass rod is brought near uncharged metal sphere. So it is initially it is what? Uncharged only, okay? It is neutral, which is mounted on an insulated stand. So there is no chance for the charge to come over the sphere. There will be polarization only, okay? So if the glass rod is removed, the charge on the metal sphere it will remain same only. If it is because there is no charge transfer happen to the sphere. So answer is 0.
Hello students, so let us continue our discussion of KCET 2023 physics paper from question 49 onwards. So let's see the question. A parallel plate capacitor of capacitance C1 with a dielectric slab in between its plates is connected to a battery. It has a potential difference V1 across its plates. When the dielectric slab is removed, keeping the capacitor connected to the battery, the new capacitance and the potential difference are C2 and V2. Okay, we have to identify the correct option. So the idea here is very simple. If the battery is still connected to the capacitor, then what will happen? The potential difference will still remain the same. So that means V2 is equal to V1. That we can directly conclude. What else? They are asking the comparison of C1 and C2. Look at all the options. So we know very well that when there is a dielectric, then capacitance is more. Capacitance becomes K times. Okay, so that means definitely C1 is greater than C2. So now we just have to see which of the option matches both these relations, and that is option 2. Therefore, this has to be the correct answer. Okay, let's move ahead. Let's take the next question. A cubical Gaussian surface has side of length A equal to 10 centimeter. Electric field lines are parallel to the x-axis. You can see the diagram also. The magnitudes of electric fields through surfaces ABCD and EFGH. So this is ABCD surface and this is the EFGH surface. They are respectively 6 kilonewton per coulomb and 9 kilonewton per coulomb. Okay. The total charge enclosed by the cube is. Now it's obvious here we have to apply Gauss's law, right? We know as per Gauss's law, the net flux is equal to charge enclosed by epsilon naught. Okay, but how will we find the net flux here? We have to look at these electric fields. One more thing which we have to be very careful about is the influx and outflux concept. Here we can see the field is going into the surface, into this closed surface. So here we have influx and here the flux will be taken as negative. Whereas here the field is coming out, therefore here the flux will be taken as positive. Okay, we can understand this from E dot A concept also. We know that flux is equal to E dot A. So if the field and area vector are in the same direction, then we'll get positive flux. If the field and area vector are in opposite direction, we'll get a negative flux. So net flux will be equal to this field but with a negative sign. So minus 6 kilonewton, so that is 6 into 10 power 3 kilonewton per coulomb into the area of this cubical surface. Edge length is given, so square of that, A square will be the area, but again here we have to be careful about the unit. It is given as 10 centimeter, so in SI unit that is equal to 0.1 meter. Okay, so this into 0.1 whole square. The other flux is positive, so that we have 9 kilonewton per coulomb, so 9 into 10 power 3 into 0.1 square. Okay, this is what we are getting. We can clearly see this 0.1 square will become 10 power minus 2, will get multiplied with this, and here we will be left with only 1 power of 10. this will become minus 60 and that will become plus 90, and therefore the total flux becomes 30 SI units. We have converted everything into SI units, so it will be in SI units. Voltmeter we can write, or Newton meter square per coulomb. Okay, the SI unit is voltmeter or Newton meter square per coulomb. Now this should be equal to the charge enclosed by epsilon naught. What do we have to find? We have to find the total charge enclosed by the cube. So let's calculate that. The charge enclosed will be equal to epsilon naught, which value they have given as 9 into 10 power 12 F per meter. That F is for farad. So 9 into 10 to the power minus 12 into this flux which we had calculated, so that is 30, and therefore we will get 270 into 10 power minus 2, which will come out to be 2.7, sorry, this was 10 power minus 12, so this was 10 to the power minus 12, therefore here we will be left with the power of 270 into 10 power minus 12, and if we try to get it in the form in which they have given the options, then we have to convert into nano coulomb. We can clearly see we have to convert into nano coulomb, and therefore this will become 0.27 into 10 power minus 9 coulomb, which is 0.27 nano coulomb. Okay, so this is the final answer. Option 2 here matches, and that will be the correct answer. Let's move ahead. Let's take the 51st question. Electric field at a distance r from an infinitely long uniformly charged straight conductor having charge density lambda is E1. Okay, and there is another uniformly charged conductor having same linear charge density lambda. It is bent into a semicircle of radius r. Okay, so both of these are standard cases. Their electric field, we must remember, we should know the final result. E1 is 2k lambda by r, or you can write it as lambda upon 2 pi epsilon naught r. This is the case of infinite line charge, and the point is at a distance r from it. This wire goes to infinity on both the sides, whereas the other case is of a semicircular conductor having charge density lambda, and at the center of this, if we calculate the electric field, then that also comes out to be 2k lambda by r, or q upon, if we want to write it in terms of q, that can also be done, but here they have given it in terms of the charge density, so directly this way we can get the result. Okay, so clearly we can see both the fields are same in magnitude, and therefore E1 will be equal to E2. The first option is the correct answer. Alright, let's move ahead, take the next question. 5 capacitors, each of value 1 microfarad, are connected as shown in the figure. Okay, the equivalent capacitance between A and B is, now at first look of this diagram of this circuit, we might feel that there is some series parallel combination which we have to apply, but we have to observe very carefully and understand here that this is in fact the case of a Wheatstone bridge. Okay, see carefully. If these points are A and B, let's mark these 2 points also. Let's say these are X and Y. Now see carefully, there is one capacitor here between AX, one capacitor between AY. This XY capacitor is the bridge capacitor. Then similarly here and here we have one capacitor between B and X, and one capacitor between Y and B. Now we can clearly see it is a Wheatstone bridge. Also we can observe all capacitors are of same capacitance. This is going to be a balanced Wheatstone bridge, 1 by 1, 1 by 1. Both sides the ratio is same. Now what happens when the Wheatstone bridge is balanced? the middle capacitor will get removed. So, middle capacitor is gone, and now we have to find the equivalent capacitance across the points A and B. Although this is a standard case, when all the resistors or all the capacitors are equal in a balanced Wheatstone bridge, then the equivalent resistance comes out to be equal to the same value itself, R or C. So, here if we try to simplify, then also we will get the same thing. This is 1 microfarad, this is also 1 microfarad, these are also 1. 1 and 1 in series will give you 1 by 2, this will also give 1 by 2, then in parallel it will again just give 1. So, our final answer will be this 1 microfarad. Alright, let us take the next question. A uniform electric field vector E exists along the horizontal direction as shown. So, this is the direction. The electric potential at A is VA, a small point charge Q is slowly taken from A to B along this curved path. But will the curved path even matter? No. Electrostatic field has a conservative nature. The potential difference between 2 points is independent of the path. So, we do not have to bother about this curved path. Okay. Potential energy of the charge when it is at point B, this is what we have to find. So, there is a simple relation between potential energy and potential. What is the relation? Delta U is equal to Q delta V. This is what we have to apply. We have to find the potential energy at B. We can say this potential energy can be written as UB minus UA, and this is equal to Q delta V. So, it is QVB minus QVA. But the answer options, if we see, they are in terms of the electric field, and in question also they have mentioned this electric field. So, how do we relate the potential with the electric field? Again, very simple, there is a relation between the two. We know very well that in the direction of the field, potential decreases, potential drops. Delta V therefore will be equal to minus EX. The value of delta V will be equal to minus EX, okay, minus E into X, minus E into X, like this, okay. Now, this delta V, then we can put here, we can put this value here, VB minus VA is equal to this, VB minus VA is equal to minus EX. For finding the energy, at point B, what we need is only this value of UB, okay. So, UB is simply equal to QVB, alright. So, UB is equal to QVB, which is equal to Q into VB value from here, which is VA minus EX, E into X, okay, E into X, and there was this charge multiplied here. So, Q into VA minus E into X. Which of the option is matching? This third option is matching, and therefore, that is our correct answer. Alright. The key fact which we need to remember here, the key concept is that the curved path does not matter. The potential difference can be directly found by taking the straight line path, and the relation between energy and potential difference also we have to use. Alright. Let us take the next question. 10 identical cells, each having EMF 2 volts and internal resistance 1 ohm, are connected in series with 2 cells wrongly connected. Very important. 2 cells wrongly connected. A resistor of 10 ohm is connected to the combination. What is the current through the resistor? Now, when 2 cells are wrongly connected, what will happen? Will the EMF reduce only by this 2 cells, due to this 2 cells? No, what will happen is they will cancel out the effect of 2 more cells. So, out of 10 cells, we can say the effective EMF will be there only due to 6 cells. Okay, this is one of the very common error which can happen here while solving. We see that 2 cells are wrongly connected, so we might take the effective EMF only of 8 cells, and that is wrong. So we can see clearly here, if 2 cells are connected like this, but all the other cells are connected this way, fine, this keeps on going, then we can see here we'll have the EMF increasing by E, but here then further the EMF decreases by E in all these steps. Or if we come from this side to this side and this is connected to an external resistor, then we are saying 8 times the EMF increases and then 2 times the EMF drops, okay, and this is equal to the total potential rise in this circuit, which will be equal to then I into R equivalent. This is equal to I into R equivalent, which will include all the resistances, the external as well as the internal resistances. Each of these have EMF E and resistance R. This is the main thing which we have to take care of. So now if I want to calculate the current will come out to be 6 times of the EMF. The EMF is 2 volts divided by the total resistance. So we have external resistance 10 ohms plus we have 10 resistances each of 1 ohm, which are the internal resistances of the battery. Remember, only the EMFs will have this effect of getting cancelled out, alright, not the resistances. Resistances will still add up. So this becomes 12 upon 10 plus 10, 20, and therefore what we get is this 12 upon 20 amperes, which will become 0.6 amperes, and therefore that will be our correct answer, alright. So this is how we solve this question which has 2 cells connected wrongly. Let's move ahead, take the next question. The equivalent resistance between the points A and B in the following circuit is, now again this is a classic infinite ladder type of question. The approach for all such infinite ladder questions is always the same. After the first step, after this first step, we can see that the pattern keeps on repeating here. So that means this whole thing is also equal to the original circuit, because it is infinity. Even if you subtract 1 step from it, it won't make a difference. So here we have X, and this whole thing also we say that it will be equal to X, the unknown resistance which we have to find. So I can draw the circuit again and show it like this. We have this 2 ohm, this is 2 ohm, this is 2 ohm, and this is our X which we want to find, and this here is also X, alright. So now we are saying combination of all these resistances should again give us the result as X, and we want to find this value of X. How do we simplify it? See, here I have X and 2 in parallel, so we will get 2X upon X plus 2, R1 R2 upon R1 plus R2, okay. Then this 2 and 2 are in series, this 2 and 2 are in series with this, so plus 4, and this we are saying is equal to again X. This has to be again equal to X. Now we have to solve this and calculate the value of X. This will become a quadratic equation, you just have to simplify further. So we'll get 2X plus 4X plus 8. I have taken LCM here. So 2X plus 4X plus 8, this is equal to, this term multiplied on the RHS becomes X square plus 2X. 2X will cancel. What we will be left with is X square minus 4X minus 8 is equal to 0. This is a simple quadratic equation for which directly we will not be able to get the roots by splitting the middle term. We will have to apply the formula, we will have to apply the quadratic formula. So let's apply it and see what do we get. So if I apply the formula, I will get X equal to minus B, so that is 4, plus minus under root b square, which is 16, minus 4ac. Now minus 4 into c value is minus 8, so that will become plus 32. Minus 4 into minus 8, so that will become plus 32 divided by 2a. A is 1, so this is what we get. This will become 16 plus 32, 48. So we are getting x equal to 4 plus minus under root 48 divided by 2. Root 48 we can further split as 16 into 3. So if I do 16 into 3, this will become 4 root 3. So this becomes 4 plus minus 4 root 3 divided by 2. Okay. And now we can clearly see that if I take the negative value, then this will give me a negative value of the resistance, which is not possible. Okay, obviously resistance cannot be negative. So only one root will be considered, which is the positive root. And if we cancel out this 2 also, then ultimately we are being left with x equal to 2 plus 2 root 3. X is equal to 2 plus 2 root 3. Now you will say, sir, there is no such option, right? So what they want you to do is they want you to find the approximate value of this, and that is why the values of root 2, root 3, root 5, these common values we must remember at least approximately. So let's put the values and see. 2 plus 2 into 1.732, even if you take just 1.73, it's fine. So this becomes 2 plus 3.464, which will become 5.464, and the closest answer which we can see is 5.5, and therefore we'll mark this answer. Okay. So the actual result which we are getting is this 2 plus 2 root 3, which we have to calculate and get the closest possible value like this. Alright. So this question is also done. Let's take the next question. Here we have a simple conceptual question based on the working of a cyclotron. Charged particle is subjected to acceleration in a cyclotron as shown. The charged particle undergoes increase in its speed. Okay. So we need to know the basics of cyclotron. In this D's, the D1 and D2, the D's, there is only magnetic field present. Between the D's, electric field is present. There is no electric field inside the D's. If only magnetic field is present, then we know very well speed can never change. There can never be an increase in its speed. So inside the D's, there won't be any change in speed, no increase in speed, only the direction keeps on changing. But between the D's, there is an electric field. In this region, there is an electric field, oscillating electric field, and that is what accelerates the charge and increases its speed in this gap in between the two D's. Therefore, this is a direct conceptual question. Only in the gap between the D's, D1 and D2, there will be an electric field which then increases the speed of the charged particle. Alright. Let's take the next question. The resistance of a carbon resistor is 4.7 kilo ohm plus minus 5%. They want us to identify the color of the third band. What is the color of the third band? Now see, this is given in scientific notation 4.7 kilo ohm plus minus 5%. But when we are finding the resistance using color coding, then we have to write first two digits without the decimal. So let's convert this into that form. 4.7 kilo ohm plus minus 5% will have to be written as 4.7 into 10 to the power 3 plus minus 5%. And this further I am saying we have to move the decimal one step ahead, and therefore it will become 47 into 10 power 2 plus minus 5%. And now we can use the color coding of carbon resistors. First digit, first band, second digit, second band. The multiplier is represented by the third band which they are asking. Okay. and the multiplier here is 10 to the power 2. This 10 to the power 2 is corresponding to the color red, and therefore our correct answer will be red. The third band is red. Others also we could have found, but they are not asking about that. Alright. So, very straightforward question based on the color coding of carbon resistors, and that is why it is so important to memorize that table. Alright. Let us take the next question, which is again based on the color coding. Okay. So, we have 4 bands. The colors are given grey, red, gold and gold. Okay. Now, once again here we have to look at this, the value of each color. Grey represents 8, red just now as we discussed it represents 2 if it is in the first or second place. Third we have gold. Gold represents 10 to the power minus 1, and again we have gold. The last band represents the tolerance, so in this case it represents plus minus 5%. Alright, let us combine this together, and therefore the resistance becomes 82 into 10 to the power minus 1 plus minus 5% ohms. Okay, this is what we get, or we can just put the unit here as per what is given, but in this form we do not see any of the options. So, this 10 power minus 1, that is 1 by 10, we will have to multiply, and it becomes 8.2 ohms plus minus 5%. Okay, option 1 matches here, and that is the correct answer. Alright. So, once again just direct application of that table which we have of color coding, and we need to know the significance of each band. First 2 bands represent the first 2 digits, third band multiplier, fourth band tolerance. Alright. Let us move ahead, let us take the next question. A wire of resistance R is connected across a cell of EMF E and internal resistance small r. So, there is a wire, let us show it by a resistance, and then there is a cell. This has resistance capital R, the cell has EMF E and internal resistance is also there, that is small r. In time t, what is the work done by the battery to establish the current I? Okay. So, if the battery is supplying current I, then we know very well the work done by the battery, will depend on how much charge has been moved by the battery. So, the charge moved by the battery Q into the potential difference through which it is increasing the energy of the charges, so that is the EMF E, and this charge itself then we can write as I into T. Okay. So, this is what we get, and if we write it in this form in which the options are given, it becomes E into I into T. One more way in which we could have approached this is we could have said the power delivered by the battery is E into I, the EMF into the current. Now, some of this power is lost against its own internal resistance also, but that is not what they are asking. They are asking the work done by the battery to establish this current, to move these charges, and therefore it will be this only. This way also if we see, then power is E into I, the power that it delivers, and into time will then become the work done. Alright. So, either ways this option 3 matches, and that will be the correct answer. Alright. Let us take the next and the last question. For a given electric current, the drift velocity of conduction electrons in a copper wire is V, okay, and their mobility is mu. So, this is Vd as per the question in the exam. In options also we can see Vd is given, mobility is mu. When the current is increased at constant temperature, then we have to tell what happens. Okay. Now, if the current is increased at constant temperature, we know very well the drift velocity is going to increase. We have this relation I equal to NEAVD. Okay. At constant temperature, number of free electrons is not going to change. E, electronic charge, is of course a physical constant, and area of cross section will not change. So, definitely Vd increases. Vd is going to increase, this is for sure. But what about mobility? And what exactly is mobility? So this is a very small micro concept which we need to know, otherwise we will not be able to solve this. Mobility is the ratio of drift velocity to the electric field, magnitudes if we take. So we know that the drift velocity can be written in terms of the electric field also. It can be written like this, minus E tau by m into the electric field. If we just take the magnitudes, then we can get rid of the vector sign, just write this magnitude, minus also not required, but this term which we are getting here, this term is then what will come as the mobility, okay, and that we can clearly see is not going to change if the temperature is constant, because E and M, once again, they are constant values, they are physical constants, charge of electron, mass of electron, and tau is the mean relaxation time, which also depends only on temperature, nothing else, okay. So temperature remains constant, mean relaxation time will also remain constant, so mu remains same, mu remains same. Combine these two and identify the correct answer. Vd increases but mu remains the same, Vd increases, mu remains the same, alright. So this completes our discussion of the physics paper of KCET 2023. I hope that you find these solutions helpful, and using this you are able to estimate and find out how many marks you are able to score, you are getting in the exam, and I hope that you did pretty well, and all the best for your future.